Hello guys, so in this video I will be discussing about infinite squarable potential. I will explain you what it is. Before that, I will explain you what is the application of infinite squarable potential. Basically, infinite squarable potential comes in quantum physics, and the application of this squarable potential has many applications in different fields, including machine learning, which is called quantum machine learning. So I will talk about the mathematics behind the infinite squarable potential and what does it says. So let's begin. Let's understand what it is. So if you see here, okay, so if you see here, you see this and this. So this is a straight. So this is a straight. Just a moment. Like this, and this, and the potential here is infinity, and the potential here is infinity, and the potential inside is 0, and this is along x direction. This is a one-dimensional infinite because it is infinity potential at, so if you see here at this point x0 till this point, which is x is equal to L. So potential is defined here like V is 0 for x greater than 0 and less than L, whereas the potential is infinity otherwise. So if any particle is kept here inside this potential, inside this box, one-dimensional box, imagine this is one-dimensional box. So even if it tries to go out of this box, it needs an infinite energy to reach any locations before x is equal to 0 or after x is equal to L. The potential energy will become infinite. The energy of the particle will become infinite if it reaches any of these locations, this one or towards this. But inside the, since the potential is 0, the particle is free to move till x0 to x is equal to L. So now we will talk about Schrodinger equation, which is called Schrodinger equation. So basically it is H psi is equal to V psi. So for this one, if you write, it is minus h square by 2m d square psi over dx2, and since the potential is 0 inside the box, potential is 0 inside the box, so is equal to, it is here, it is not v psi, it is e psi. So what is psi? So psi tells about the wave function. And what is E? These are the energy, possible values of energy which the particle can take inside this box. And the psi tells the wave function, where it also tells about at which location, what is the probability of finding the particle. Say, in this box, if particle is, we can find here, if particle we can find here, or which x would you find a particle at different energy states. So as the energy of the particle rises, the wave function changes and the probability of finding the particle inside the box at different locations will change. If you solve this equation, you will find that psi here, psi, the wave function is a sine kx, where k is wave number and x is the position coordinate. We know that the wave function is 0 after x is equal to L or before x is 0, because we cannot find the particle before x 0 or after x is equal to L, and that's the reason we have to put size 0 at x is equal to L. So these are the boundary conditions. So if you put psi is equal to 0 at a sine kl, you find, since amplitude cannot be 0, so kl has to be some integer value of pi, some integral value. So it is 1, 2 or 3. So if you solve this, you get k is equal to n pi by L, and since k, the value of k is root 2me over h cross square n pi over L, and e comes out to be n square pi square. Here you have h square over 2ml square. So these are the energy values which the particle can take. So now if you come here, so we know that now the energy values is n square pi square h square over 2ml square, and the wave functions at different energy values is root 2 over L sine, this is n pi by is coming n pi x over L. So we have these wave functions. So I will be discussing more about the interpretation now. So first energy values, if you plot the energy values, so first energy value which is possible, second and third, if you see, so first is some value which is say here, second value will be somewhere here, third value will be somewhere here. These are the energy values at different n. These are at different n. So first energy value can be extracted by putting n is equal to 1, and that comes out to be pi square h square over 2ml square. Second comes out to be 4 of pi square h square by 2ml square. So we can say E2 is 4 times E1. Likewise, E3 is 9 times E1. So the first ground state energy is say pi square h square over 2ml square. If you calculate this value for 1 gram of mass, then it comes out to be, E1 comes out to be 5 into 10 raised to the power minus 61 joule. This is the value for mass 1 gram kept in an infinite potential, which can stay here in the limits of 0 to L, but cannot go outside these ranges. So minimum energy will be this much, 5 into 10 raised to the power minus 61. As it attains more energy, if the particle has been given more energy, if it attains those energies, it exhibits different probabilities of being found inside the box. So for n is equal to 1, say this x0, and this is x is equal to L. So for ground state, this is something, this is for the first ground state, this is the second state inside the box. This is the box, this is the box. So just a moment. If you try to make it straight, this, okay. And then third is like, if you make it straight like this, it goes like this. Okay, so this is x0, this is x equal to L, and the particle, okay, so this is n is equal to 1, this one is for n is equal to 2, this one is for n is equal to 3. So n is equal to 3 means it has the third energy state, n is equal to 2, that means second energy state, and n is equal to 1, that is first energy state. Means if the particle is kept freely inside this box infinite potential, minimum of 5 raised to the power 10 minus 61 joule has to be there if its mass is 1 gram. If it will be there without the energy being given to it. And probability of finding that particle inside the box you see is maximum at x is equal to 2. Sorry. Okay. So I was saying okay, x is equal to L by 2. This is the position. And when you raise the energy, when the particle attains more energies, the wave function changes, and the probability of finding the particle at different locations increases. Like I will explain you here. If we create the probability map, so for first one it will be like this, so for second one it will be like this, for the third one it will be like this. This is the infinite square well potential. So you see, here is x0, here is x is equal to L, and here is x is equal to L by 2. And you see, when in the ground state, that means the first energy state, the maximum probability of finding the particle is in between. Whereas in the first energy state, the probability of finding the particle just in between is 0. You cannot find that particle in between. That is the mysterious things which quantum effects shows. Now again in the third state, you can see the probability of finding the particle in between is again its maximum. But if you see the third state, there are 3 points which has the maximum. So the probability of finding the particle here, here and here, these locations is maximum and equal. Whereas in the second energy state, there are 2 locations where you can find the particle with maximum probability. So that means as the particle is attaining more and more energy states, more and more locations, more and more points like these are coming, and more these points are coming. That means more probable the particle to be found at different locations. In the first state, it is very definite that you can find the particle just in between. That is what it is saying. Whereas as the particle attains more and more energy, the probability of finding the particle at different locations are equal, and it can be found anywhere inside. That's what it is saying. So more energy it attains, more freedom it has inside that potential. Thank you for watching this video.